Hello, cuddlers, and those who need a cuddle. My name is Ken Sipe, and I'm here to present a presentation on a new project that we've created called KUTTL, and provide some of the history behind it as well. So first of all, my name is Ken Sipe. That's how to get a hold of me. It's Ken Sipe on Twitter, or Ken at Day2IQ, and I'm one of the application engineers. I've been a contributor on Mesos and on Kubernetes, as well as one of the core members on Kudo and KUTTL. So if you have any questions, get on the Slack channel or go ahead and hit me direct. We'd love to correspond. So what is KUTTL? Well, KUTTL stands for the Kubernetes Test TooL, or KUTTL. But where did it come from? The origins of Kubernetes, the origin of KUTTL, it was built as part of a test harness and framework inside of Kudo, which Kudo is the Kubernetes Universal Declarative Operator. In the spirit of building a project that is based on declarative operators, it made sense for us to take a look at a declarative way of testing. And so a test harness was created. Based on its creation and its interest, a number of other projects took interest for that harness. And so we have extracted that out into its own project called KUTTL. So what is KUTTL? KUTTL is a test framework, of course, and a test harness. Where does it fit into the ecosystem of testing? As you can see here, it's really not used for unit tests, so it doesn't fit in there at all. You would use it for integration tests or E2E tests. And the minor differences between those two, I guess, but what we think of when we think of an E2E test is end-to-end. From an end-to-end perspective, you could be testing all the way from client-side CLI execution against a cluster, and testing inside of the cluster and the state of that cluster, and that's what the E2E capabilities are. So who would need a KUTTL? If you are writing operators, writing controllers, using Helm charts, if you have if you're creating any kind of code that would change the state of a Kubernetes cluster in any way, one option is to not write a bunch of extra Go code, although you probably would write your unit tests. But if you want integration and end-to-end testing, and you want to do that in a declarative way, this is for you. This project is for you. As we mentioned, portable end-to-end integration tests with Kubernetes. What we really mean is I want to be able to gamble, as you see here on the screen, and I want to assert that that is true. We're saying that the subset of data within this YAML is represented as a truthful state within the Kubernetes cluster. So that would say in this particular example that there is a deployment that exists, that its name is example deployment, and that the current status is it's ready with replica support. Anything else is not tested, not interesting, not asserted, but this must be true. How do you get started with KUTTL? Well, at this point, the only option is to either download the binaries directly, which are available on the release site, or to do a brew install of KUTTL CLI. There is a PR out to be able to include this into crew, in which case then you could do a kubectl crew install KUTTL CLI. And those two approaches would be what you would need if you wanted to be able to run KUTTL without writing any code whatsoever. But if you have your own testing that you want to integrate with, and you want to be able to integrate KUTTL in the test harness that KUTTL provides into your own code, you could do that as well. And at your Go project root, you would do a go get Kudo builder KUTTL, and that would pull whatever the latest release is. And in this case, it's version 0.10. So the abstract is, as stated, was that KUTTLing releases cocktail hormones, which can lower your blood pressure and heart rate. And anybody who's creating Kubernetes controllers or Helm charts clearly could use some help in the blood pressure and heart rate area. And as you can see here, indicated on the World Wide Web is the fact that KUTTL can do that. And of course today is April Fool's, but we still think testing can lower your blood pressure. So who were the first KUTTLers? It would be useful to call out certainly Justin. When we first created Kudo, the idea of a test harness, the ability to use a test harness and to do it in a declarative fashion was really envisioned by Justin, who was the original author. Jared and Tom were among the two who were early creators of Kudo itself, and then helped out in that fashion as well as getting the test harness in place. And I'm calling out Zan especially as well, because Zan is one of the, he's building operators with Kudo, heavily focused on Kafka, because of the amount of time he spends with it, he's really enriched our understanding of what we need within KUTTL. And then, of course, you can see here some of our core KUTTL members as well, with Elena, Alex, Jan, Marcin, and Andreas. So that's a quick introduction of KUTTL. Here's our agenda. We'll do a lot of KUTTLing today. We'll walk through why would you want to KUTTL. We'll write your first KUTTL, and we'll progress all the way forward into KUTTLing in action. Why would you KUTTL? Well, as we stated, KUTTL is about a declarative testing. And what does that look like? Well, we want to declare at least a couple things. We want to be able to declare the creation or update of a test object. In this case, I want to be able to create a pod with a certain specification. But I also want to be able to declare in YAML something that we're very familiar with, an assertion. So I want to be able to assert that this is true. And this is a fairly simple example. It doesn't have a status that we're asserting, which is also possible. In this case, we're just asserting that this object was created within the cluster. The terms of service. Well, we have a few terms that are listed here. The first is a test suite, which is just a collection of tests. We have a test, which is a collection of test steps, and that might be fairly new to other testing tools. A test step then is a step within a test, and it's indexed, as we will see. It's in a step that we would have a collection of CRUD-like activities. I want to create something, I want to update something, I want to delete something. And then at the completion of a step, I want to assert something to be true. I want to assert that it exists, or I want to assert that if it does exist, it's an error. And then we have the final term that's worth noting is the test assert. The test step and the test assert are also kinds that are defined, and you'll see this in some YAML examples where we can hint towards certain things. Like in the test assert, I can declare that this will take longer to run, or I want to somehow change the timeout expectations for this test. So walking through those in detail, the test suite basically comes down to two separate concepts. The first is that it's a folder. So you can see here on the left that we have test data. We have a number of folders in there. Each one of those folders represents a test. The name of the test is the name of the folder. So we can see CLI test. We see CRD and step. We see list pods, which has been expanded. Those are tests. So the test suite is this folder that contains all those tests. The other thing that would represent a test suite is it's actually a kind within KUTTL, and there is a configuration file. So the configuration files you see here, where we have the kind of test suite and whatever kind of configurations that we'll go through in detail through this presentation. At the core of it here is we're saying we do want to start control plane, and we've defined what the test directories are and how many threads do we want running and running these tests. So that's a test suite. The test itself, as we mentioned, was really just a folder. I gave the example earlier. You can see this pointed out here on the slide. List pods is also, we could refer to it as a test. It also holds the collection of test steps. The test step itself is also made up of two concepts. The first is that it's a indexed set of files within a test. So in this case, the list pods has a 00 assert and has a 00 dash pod. Those two things make up a complete step. One would be changing the state, the other would make some kind of assertion. The other thing is that a test step is a kind. So based on the kind, we can do certain things. So within a given step, I might want to invoke certain commands. In this particular case, you can see that I'm doing a kubectl apply of a YAML and asking that it be honored with namespaces and this kind of thing. Those two things work in concert to be able to create what we call a test step. And there is no defined limit to the number of steps, although it would be reasonable not to have hundreds or thousands of them, I suspect. And then we have the test assert. So with the test assert, once again, it's a couple of concepts. The first is that you have a assert file, so a step a step index, 00 in this case, with an assert file name. That is somewhat special, and that's all you would need. You could just put in an assertion of YAML at this point, but you could also include multiple YAML documents. In this case, on the right, you can see this. The two YAML documents include an object, which is the test assert, which changes the timeout to 20 seconds instead of 30. You can see then the state of a pod that we would expect to be true within 20 seconds. And then we have the KUTTL test suite. So the test suite, again, as you can see, is in the example. I say Kubernetes or KUTTL test, and I send it the package that I want to test, in this case package test data. And then this will spin up. You can see at the very bottom of that output, we have the CLI test, the CRD in step. We have the create or update. Those are all tests that have been identified as we spun up the test harness from the CLI. Well, let's build your first test with KUTTL. This will be your first KUTTL. And you will need kind on your machine and the KUTTL CLI. The first thing that we might do is create a series of directories. And if you look at the folder here with E2E, that would be the test suite folder. Underneath the test suite folder, we'll create another directory, which is our example test, and that will be the test that we are creating. Within that test folder, we will create a file that's indexed starting at 00, so 00 dash some meaningful name.yaml, and then any kind of Kubernetes YAML. In this case, we are creating a pod named pod 1. It has Nginx in it. In this case, because it is not an assert, it would be created if it wasn't in the cluster already. The next step would be within the test step, we would also have an assert file. So 00 assert.yaml. We understand that the 00 pod would be invoked first. It's part of the first part of the step. And then the assertion would occur after that. So the assert here would just assert that a pod was created. And actually, it's not even testing the status of the pod. It's just asserting that this object exists within the cluster. Now that's everything we need to test for this particular test case, or this test. We need one more thing, and that is the KUTTL-test file within the root directory of the project. In this case, we're defining the test suite and the test directories. You can override that through the command line, but we do need this file to exist. Then we can run it. Here you can see kubectl KUTTL test and start control plane equals true. You can see that it starts up. You can see that it's pulling out the example test and that this particular example passes. And you can also see that it's using the mock control plane, and we'll talk more about that later. Additionally, assuming that you had more tests than this, let's assume we had more folders with more tests for our test suite. Maybe you just want to run one test. You don't want to run the whole set of folders. That can be done as well by passing in the --test and the test name. So in this particular case, --test, example-test will look at the test suite and then just run the one test called example test. Well, let's look at the ways we can KUTTL. One way we've talked a lot about so far was the KUTTL CLI, and if you get the help, you can see that it has limited feature sets, really. It can test and it can provide the version. Another option would be to integrate KUTTL within your Go project. In order to do that, using examples from our Kudo, here you can see that I am pulling out the harness, I'm pulling out test utils in the test folder, or the test package, I should say. Somewhere in the code, I have options set to the creation of the test suite. If you wanted to modify this in any way, not using our test suite file format, well, first of all, you could use the format and you could just marshal it in. But additionally, you could just programmatically create whatever you want here. And then in the final block of code at the bottom, you can see that we have a run occurring. So we establish the harness using this test suite options, and then harness.run will run whatever is defined within the test suite. And then of course is added to the t-test, which is the standard Go testing. And that's it. So we see the two different options, the CLI and the option for integrating it within Go. Whether you're using the CLI or embedding KUTTL in your own Go project, it's super useful to know or understand the test suite structure. So looking at the structure, you can see that there's a CRD directory and a manifest directory, and then testers, which is the test suite folders, of course. Regarding the CRD directory, the manifest directory, it's very common that KUTTL is used to test operators, and it's very common to have CRDs with those operators. The one thing to know about CRDs is that common that it takes some time before they are realized, available within the cluster. So when the CRDs are added into the cluster, there is a wait period of time in test setup to wait for the CRDs to be available, which is not there with regard to the manifestors. And the manifestors are just other manifests that you want to have applied to the cluster for the test suite. And then you'll see a series of control plane type things. We'll go into more detail on that in another section. Additional within the test suite configuration is there's a very tight integration with kind, and you can specify that you want to start with kind, that you want a whole kind cluster started up. You can specify a new kind context other than default that is used. And there's ways to be able to pull Docker images and make sure that they're available on all the nodes. This is really useful when you don't have a released on GitHub version of an image. And then finally, with the completion of the test suite configuration, the ability to skip delete. Normally a cluster is cleaned up afterward, after the tests are complete, but perhaps you want to debug it. You could also say that you want to skip the cluster deletion, leaving the cluster available to analyze. You may want to change the number of parallel or threads that will be used by default. And you also have control over the artifacts directory, the directory of output. By default, it's the current directory. So if you want the folders to be established in an artifacts directory, then you would need to specify what that directory is. And then you have a list of commands, and the commands are commands that you want run prior to the execution of the test suite. To give you an example of that, here is a KUTTL test YAML file, and as you can see here that it defines a test suite, that we do want to start kind, that we have testers defined in the test E2E, that we have manifests available in the test manifest folder, and that our CRDs are defined in test CRDs. There's a lot of options for the CLI, for the test feature of the CLI. Here are some examples that are provided at the command line. If you just ask for help, these would be provided. You can see a number of options here. You could specify a new config file, maybe a new named config file, not the default name, I should say. We could override something that's actually defined in the configuration file, and I think you'll find that very useful. So let's talk about where we might KUTTL at. What we're really talking about is what test environments we have. And there are three options available to us. The first is a live cluster. The assumption is that you've created this cluster, that it could be any cloud provider, it could be a different development cluster like Minikube. It's some other option, right? And in all likelihood, the reason why you might choose that as a live cluster is to test in a real live cluster environment on the cloud that you're interested in, or because it's very large, or because you have needs that are very special. So you have nodes that are tied some way to GPUs or something of that kind. That is available to you using KUTTL, and you would pass it then like you would a normal configuration for Kube. So kubeconfig. Our next option would be kind, and that can be specified through the test suite file, where you would specify start kind, :true. Or you could do it at the command line by saying -- start kind equals true. And then there's lots of additional kind control options, which we'll see on the next slide. Those two options, the live cluster and the kind, is what we would refer to as our E2E options. They would be options available testing throughout the cluster, and they test up against real clusters. The next option would be to have a mocked control plane. With the mocked control plane, what you can imagine is essentially the startup of an API server and etcd, and that's it. So there's no controllers that are controlling the operations of different objects. You can interoperate with the API server, and you can verify that the state of things was recorded or can be manipulated in some way. So the mock control plane is used for more of an integration test. It's not full featured, it's missing controllers. And you would start that by saying start control plane :true in the KUTTL test file and the essentially test suite file, or at the command line via the -- start control plane. Looking at our kind cluster, there's lots of different options. In particular, you can specify a configuration for kind. So you have your own way of creating a kind cluster and it's identified in a YAML file, you can then specify it. It's a standard kind configuration file. So you would look to kinds documentation for what's possible with that. You can specify the kind context. You can preload using the kind containers. You can preload images, which can be super useful if you have images that are not available on Docker Hub. They're not released images, but you want to pre-populate those images. Additionally, the images are already there on the nodes so that when startup occurs, there's not fetch time associated with it. And then we've seen this before, but to round out this slide, there's the ability to pass in at the command line skip cluster delete, which would allow the cluster to remain available in order to do some analysis and that kind of thing. Well, we've already created an example KUTTL test and test suite, but perhaps there's more for us to know and understand around the tests themselves. So let's take a look at the autonomy of a KUTTL. Let's first look at the test steps, their files and formats. The first to note is that those files are YAML files. KUTTL does allow other files to be in the test suite folders, and those files are ignored. So the most common use of that would be documentation, where you're documenting the expectations and understanding of the test. The next thing is the actual test steps themselves. It's an index dash and a step name, and then of course a YAML file. In the example you see on screen now, we have 00 pod, 00 example, 01 staging. This example doesn't even have an assert or errors. It's just potentially setting up a cluster with certain conditions, and it's a completely reasonable thing to do with KUTTL. KUTTL can be used in this way where we're just setting up a series of things that need to be applied to a cluster. When looking at a step, in this case an index number 00, all of the files with that index are evaluated first, and then errors or assertions are applied. And in this case there are none. It is possible to have multiple YAML documents in a given file. It's very common to see. And now let's take a look at a little bit more detail on what happens with those files. So a test step, when we have an index and a file that's not an assert or an error, what happens with it? If the object doesn't exist yet, it will be created in the cluster. If it does exist, then it will be updated. And what's important about this is that it's a patch update. So it's not necessary to declare all aspects of the object. If you just want to update one element or a label of that object, it will be patch updated with whatever's defined. So you can be somewhat brief in the test files. It is also possible to delete during a test step, but it's required to use a test step object to do that. So to delete an object with a test step, this would be an example. First of all, we have within our file a test step and a delete. And you can see here we're deleting a pod, the first one is. The second one is deleting all pods that match a certain label. And then the last one is to delete all pods. So you can see how the more verbose you are, or the least verbose you are, has a huge impact on what will actually happen within the cluster. It is also possible, just like at the test suite level, at the test step level, it's possible to apply commands. So here you can see an example of applying a file, or in the example with KUTTL, we're actually doing a KUTTL install of something for that step. Any kind of command that you find available on that platform is possible within this test step. So let's talk about asserts and errors in the format. The first is that we have an index-assert or index-errors.yaml. With the assert, we're asserting that something is true, that it is met within a certain time limit. The default is 30 seconds and can be redefined. The other is errors, and that is basically the test that something should not exist. It's the absence of an object within a given period of time. An example of this is we have just a standard Kubernetes object here. We have a pod with a name where the status phase is successful. So in this particular example, we're asserting that there is a pod, that the name of it is my pod, and that the status phase is successful within 30 seconds. Now, it is possible to remove the name my pod, in which case, if that were part of the assertion, it would mean that it's any pod that has a status phase equal to successful. No other fields are evaluated at the time of this assertion. Let's talk about a couple of cuttling tips. First of all, Kubernetes events are objects. So here's an example of asserting that an event occurred. In this particular case, an event occurred that involved the pod named my pod. As long as there is an event that is started that happened for that pod on the Kubernetes events, then this would pass. It is possible that you have a step that actually creates a CRD. Unlike the start of the test suite, when we specify CRDs there, we wait. But when you're in a step, there's no way to describe to wait. So the proper way of waiting would be then on the left here to create an assert after you've applied the CRD, and this assert asserts that the CRD is available and that the status indicates that that CRD can be used. And then the next step in your test would include then the use of that CRD. There's more details on our documentation site. It is also possible to use Helm. Now again, we're using Helm within the commands that can be done at the test suite, or it could be done at the test step. So here you can see that we do a Helm init, we do a Helm delete, we do a Helm install. All of those are possible to be leveraged via a test. Well, we've already used KUTTL in some examples to test out simple Kubernetes objects, but KUTTL was really created initially to test out operators. So let's take a look at kuttling our operators. When we talk about operators, it's challenging to talk about them without talking about CRDs. So the first aspect is that we have the ability to initialize or start up a cluster with CRDs. That can be specified with the CRD dir or with --CRD at the command line. When using that, of course, as we've already stated, the CRDs would be installed, those objects would be created, and then there's a wait to verify that those CRDs are available. The other component of a standard operator is the controller. Now, using KUTTL as an example, it is possible from the CLI of KUTTL to install the KUTTL manager. So here you can see KUTTL init --wait. And the great thing about that is the init will actually install the latest release of KUTTL. So this assumes that you have a release, that it's not part of the development, and the --wait will wait until the manager is available. So it's kind of the readiness probe built in. So this command will run, it will run until completion. Upon completion, the test will then continue. So this is one way. This would be the way to install like a controller or something like this that has already been released. In dev though, we want to be able to test with artifacts that are newly created or maybe not released. So in this particular case, we've added in actually a new command that's not even fully documented yet, or a new attribute to the command, and that is background. So here you can see on line 6 of the example that we have a command that initializes KUTTL but only does the CRDs, assuming you don't have CRDs established in another way. And then we have a command that is executing the manager. In this particular case, we actually do a make manager prior to executing the KUTTL, and then the manager is created in the bin directory. Based on that, we will then execute that in the background. In this particular case now, we could be testing the manager that just hasn't been released yet and verifying that it passes the KUTTL tests. Let's take a look at KUTTL in action. What I want to do for this is show a couple of examples that we have within our projects. The first thing to note is that KUTTL uses KUTTL to verify certain aspects of itself. And so let's take a look. Let's start with looking at KUTTL. As we stated, KUTTL is used to test KUTTL. If we look on the left, you'll see that the test suite is defined. We're going to override the test dirs. We're going to actually start the control plane. Everything that's over there is kind of what's necessary to get started. We're going to test the package test data, which is defined over here. We should see a CLI test, a CRD in step, a create, update, delete, that kind of thing. Let's hit start. We can see the test harness has started. It is going to create a mock control plane and runs relatively quickly, and everything passes. Let's take a look at what types of tests were being done. Things of interest. First, we have the list pod. We've already seen this example a number of times. This will be created, and then we'll assert that this exists. It's just testing the pod creation. The CRD in step. Well, we have a CRD The CRD is defined here. We are going to assert then that the CRD exists, and this really is to ensure that it's even possible to leverage the CRD. Had we not had this assert, it is likely that this next create would fail. So the next step here, 01, is the creation or use of that CRD. That would likely fail had we not waited, and actually will probably be flaky. It's unclear as to whether it would be a failure or not, but it's possible. And then we're going to assert that we actually leveraged or used or created an object of that CRD. Another one that might be interesting is the CLI. So here we're going to create a pod, and we're using the CLI to do that. We're going to assert that the object was created, and we're going to apply some patches. So we make some adjustments to labels. Notice one other thing that's useful to note here is that we have a command that is clearly designed to fail, but it's ignored. Had this not been annotated as ignore, this failure or a command failure would have been a test failure, but in this case, ignore that. And then we have an assert that the pod and its labels were changed. And then let's talk about maybe a delete in step. Here we have step 1, create. So we have a couple of pods here. We have a pod that's being created. And what's important here is that the names of these pods, we have hello and hello 2. We assert that they exist so we can verify that those are true. Notice that we have multiple YAML documents defined in the assert. In the create here, we have some things that are kind of different. So we have a test step defined, and it's going to delete all pods. And that's the way it's annotated here. And then we're going to create a couple pods. Notice that it's hello and hello 2. This would not be possible. This would have failed if this delete did not happen. So delete occurs, these two things are created, and then we assert that those things exist. And that's it. That's a quick run through of KUTTL. That should give you hopefully enough information to get started. Let's move forward in the presentation. Well, let's talk about the future of Kuttling. The first is to note that we just had our 010 release. Even though that was a relatively recent release, it's important to note that there's been a year of development while it's been used within KUTTL. So this isn't just fresh bits that just landed. This is some bits that have been around for a while that have been separated out to be leveraged and used across different platforms or different projects, that is. We're super excited about leveraging it. We're super excited about sharing this with the SIG testing, with trying to get this in the sandbox for the CNCF, a variety of things. So please look forward to seeing that. And if you have feature requests, we would love to see them. We'd love for you to be involved. And with that, let me make a call for action. Get involved. The KUTTL project is completely open source, available on GitHub, as you see here. We still are using the KUTTL Slack channel to monitor and work with details associated with KUTTL. If the project grows to be large enough or with enough demand, we may need to separate that out. It's unclear at this point, but for right now, the volume of activity is perfectly fine and still tightly used within the within the KUTTL space. So we're still leveraging that. If you're looking for docs, we haven't ported those over yet. That should be here shortly. Frankly, it might be there by the time this presentation is seen. So take a look at that on KUTTL under the test docs, but expect it to be under KUTTL. Either kuttl.io or kuttl.dev, probably both of them will work. We own both of those. And then we use the KEP process. So the Kubernetes enhancement process has been simplified into the KUTTL or the KUTTL enhancement process, but there is a process available. It's very familiar with anybody in the Kubernetes ecosystem. And please, that's where to look and see how decisions were made. That's where we start to drive everything in the public space. And again, we do have a community meeting that happens twice a month. That community meeting is the KUTTL community meeting. That's where to get our attention with your needs that you might have with KUTTL. We would love for you to help us in making this a project that is valuable across many of the operators, controllers, and any kind of Kubernetes project that makes state changes to the Kubernetes cluster. And with that, thank you for cuddling with me. And I hope this was extremely valuable. I would love your feedback. So, ping me on Twitter at KenSipe or hit me on email or on Slack. Let me know if this was of value to you, and have a great day.